Have you ever looked up at the night sky and wondered, where did it all begin? The vast expanse above us, dotted with countless stars, holds secrets that stretch back to the dawn of time. Our planet, teeming with life, oceans, and continents, was once just a swirling cloud of dust and gas. This cloud, seemingly insignificant, held within it the potential for everything we know today. It's a story that stretches back billions of years, a cosmic drama of epic proportions, and it all started with a bang. The Big Bang, an explosion of unimaginable energy, set the stage for the universe as we know it. Imagine a vast swirling cloud, a cosmic nursery filled with the remnants of ancient stars. These remnants, the ashes of long-dead stars, carried the elements necessary for the birth of new celestial bodies. This is the nebula, the birthplace of our solar system. Within this nebula, the seeds of planets, moons, and even life itself were sown. Within this chaotic dance of particles, gravity acted as a sculptor, pulling dust and gas together. This gravitational pull was the invisible hand that began to shape the future of our solar system. As more and more material clumped together, our young sun began to ignite at the center, bathing the surrounding disk in light and heat. This ignition marked the birth of our star, the sun, which would become the heart of our solar system. The story of Earth begins within this maelstrom. Amidst the chaos, tiny particles began to collide and stick together, forming the first building blocks of our planet. It wasn't a sudden appearance, like a rabbit pulled from a hat, but a gradual accumulation of cosmic debris. Over time, these particles grew larger, drawn together by the forces of nature. Dust grains, drawn together by electrostatic forces, began to stick together, forming larger and larger clumps. These clumps, though small at first, were the precursors to something much greater. Over millions of years, these clumps grew into planetesimals, the building blocks of planets. These planetesimals collided and merged, gradually forming the planets we recognize today, including our own Earth. The early Earth was a molten mass, bombarded by asteroids and comets, gradually cooling and solidifying. This tumultuous period set the stage for the development of the planet's surface and atmosphere. As the Earth cooled, water vapor condensed to form oceans, and tectonic activity began to shape the continents. This dynamic process created the diverse landscapes we see today. In the primordial oceans, the first simple life forms began to emerge. These early organisms would eventually evolve into the complex web of life that inhabits our planet. From a speck of dust in a cosmic dance to a vibrant living planet, Earth's journey is a testament to the incredible processes that govern our universe. And as we look up at the night sky, we are reminded of our place in this grand cosmic story. The Protoplanetary Disk, a swirling disk of gas and dust, was a chaotic but fertile ground for planet formation. Within this disk, particles collided and stuck together, gradually growing in size. These collisions weren't always gentle mergers. Some were catastrophic impacts that reshaped these early planetary embryos. The early solar system was a cosmic shooting gallery with planetesimals of various sizes zipping around, drawn by the sun's gravity. Earth, still in its infancy, would have experienced countless collisions during this period. Each impact contributed to its growing mass and helped shape its future destiny. As Earth grew larger, its gravitational pull intensified, attracting even more material from the surrounding disk. This process, known as accretion, continued for millions of years, steadily increasing Earth's size and mass. But it wasn't just about getting bigger. These collisions also brought with them a cocktail of elements and compounds that would shape Earth's composition. Imagine a ball of molten rock, glowing with the intense heat of its formation, a seething mass of fiery liquid that would one day become our home. This was Earth in its early years, a fiery inferno constantly bombarded by cosmic debris. Asteroids and comets relentlessly pounded the surface, adding to the chaos and heat, shaping the young planet in a violent dance of destruction and creation. But within this chaos, a remarkable transformation was taking place: differentiation. This process, driven by the intense heat and pressure, began to sort the materials within the Earth. setting the stage for the planet's future structure. As Earth cooled, denser materials like iron and nickel began to sink towards the center, forming the core. Meanwhile, lighter materials, such as silicates, rose to the surface, creating a primitive crust. This separation of materials was a crucial step in the development of Earth's distinct layers. This separation of materials led to the formation of Earth's distinct layers, the core, mantle, and crust. Each layer has its own unique properties and composition, playing a vital role in the planet's overall structure and function. The core, a sphere of solid iron and nickel, lies at the heart of our planet. This dense metallic center generates a powerful magnetic field that extends far into space, shielding us from harmful solar radiation and cosmic rays, making life on Earth possible. Above the core lies the mantle, a thick layer of hot, viscous rock that churns and convects over geological timescales. This slow but constant movement drives the motion of tectonic plates on the surface, influencing volcanic activity and the formation of mountain ranges. Finally, we have the crust, Earth's outermost layer, where we live and build our civilizations. This thin, rocky shell is the foundation of our continents and ocean basins, providing the resources and stability needed for life to thrive. This thin, rocky shell is divided into tectonic plates that constantly shift and interact, giving rise to earthquakes, volcanoes, and the majestic mountain ranges that grace our planet. These dynamic processes shape the landscape, creating the diverse environments that support a wide variety of ecosystems and life forms. The early Earth was a world of fire and fury, its surface a landscape of molten rock and erupting volcanoes. Imagine a time when the ground beneath your feet was constantly shifting, and the sky above was filled with ash and lightning. This was a planet in its infancy, a place where the forces of nature were at their most raw and untamed. Volcanic activity played a crucial role in shaping our planet's early atmosphere. These eruptions were not just destructive, they were also creative, laying the groundwork for the complex world we live in today. The gases released by these volcanoes were the building blocks of our atmosphere. As volcanoes erupted, they spewed out a noxious cocktail of gases, including water vapor, carbon dioxide, nitrogen, and sulfur dioxide. These gases mixed and mingled in the sky, creating a thick, toxic blanket that enveloped the planet. It was a harsh environment, but one that was teeming with potential. This early atmosphere was a far cry from the air we breathe today. It was a world where the very air could kill you, a stark contrast to the life-sustaining atmosphere we now take for granted. The transformation from this hostile environment to the breathable air we enjoy was a slow and complex process. It was hot, dense, and toxic, devoid of the oxygen we need to survive. The sky was often darkened by volcanic ash, and the ground was scorched by lava flows. Yet in this seemingly inhospitable world, the seeds of life were being sown. But it was a crucial step in Earth's evolution, providing the raw ingredients for the life-giving atmosphere we enjoy today. Over time, these gases would interact with each other and with the planet's surface, undergoing chemical reactions that would gradually transform the atmosphere. The outgassing of volcanoes wasn't a one-time event. It continued for millions of years, steadily pumping gases into the atmosphere. This relentless activity ensured a constant supply of the essential elements needed for the next stages of Earth's development. As Earth cooled, water vapor condensed to form the first oceans, while carbon dioxide dissolved into the water, forming carbonic acid. These early oceans were the cradle of life, providing a stable environment where the first simple organisms could begin to evolve. This acidic rain weathered rocks, releasing minerals and salts into the oceans, setting the stage for the emergence of life. These minerals and salts were crucial nutrients, feeding the earliest forms of life and allowing them to thrive and multiply. From these humble beginnings, life on Earth would eventually diversify and evolve into the myriad forms we see today.